Good day, sir. It is an honor for our group to present our project for ELE355, and our project is titled Water Level Control System using the BC547B transistor. These are our group members involved in our project. First is me, Rajo Tajang. The next is our member Fedelista Bin Fernandez, Anak Sansik, and last but not least, we have Malcolm Thompson, Anak Uging. So we'll now start with our introduction to our project, where first our project uses BC547B transistor to detect water levels and control a pump. Next is manual monitoring is inefficient and prone to human error, so this is one reason why we made this project. The next is our water level control system also helps to manage water efficiently and automatically. And lastly, our system uses a low cost, simple, and is suitable for home use. So now I will move on to our problem statement, where firstly, nowadays people will now usually manually monitor their water levels at home, but this is very time consuming and will often lead to human error. And because of this human error, there will be a lot of uncontrolled water filling, which can cause overflow in the water tanks, which will then lead to water being wasted, or it can destroy property damage. Then next is forgetting to turn off the water pump, which can result in high electricity consumption and motor burnout. Lastly is the existing automated systems in society and houses nowadays are often complex or expensive, making them unsuitable for small scale or household use. So now I'll be talking about our objective. Our first objective is to build a water level control system using the BC547B transistor. This is so we can detect low, medium, and high water levels in the storage tank. So we can also automatically control a relay to turn a water pump on or off, which will prevent overflow and dry run conditions in the tank. I will now let Fedelista take over to present about our methodology.
For methodology, this will be our block diagram. For input, the input will be a water tank. And then for the sensors for our project will be using transistors. Each transistor is connected with a float rod that is placed at a different level. For the quarter level is 1 over 4. Second is 1 over 2 of the level, which is half. And lastly is full level. The output is listed as below, which is LED will light up when the water has reached a certain level. Relay will connect the motor circuit when the water tank is full, and motor will switch on to turn the water valve off. This is our datasheet for this project. For this circuit, we'll be using BC547B. This will be our proposed circuit. The design specification is listed as below. Firstly is the VCC is 20 volt. The transistor is BC547B, and the configuration for our circuit is voltage divider, bias, common emitter. This is our simulation circuit for PCB fabrication. This is the PCB layout, and this is the 3D layout for the front and back view. For financial management, firstly is BC547B transistor. The price will be 3 ringgit 29 cents and the quantity will be 3. Second is LED. The price will be 50 cents and the quantity will be also 3. And lastly is the relay. The price is 5 ringgit and the quantity will be 1. For simulation circuit order operation, for the first level, which is half of the water tank, if the water has reached a certain threshold, the first LED will switch on. This is also the same for the half level of the water tank, which is the second LED will switch on. And then lastly, when the water is full, result for the water level is full in the water tank, which means the third LED will light up. This will cause the relay will be activated, completing the relay circuit, and then the motor will be activated. Okay, for the water level control system simulation, we'll be using Purchase at Professional to conduct the simulation. For the first part, when the water level has reached 1/4 of the water tank or the quarter level, the first LED will light up as seen here. And then, if the water level has reached 1/2 of the water tank, which is half of the water tank, the second LED will light up. And then lastly, if the water tank is full, the third LED will light up and also it will complete the relay circuit. This will cause the motor will be activated. This motor will act as a stopper for the water level tank.
My name is Makato-san, and I will continue the presentation by presenting the result and discussion. So the first one is our simulation circuit. As you can see, this simulation circuit is being tested using multi-sim. So the second one is our circuit analysis. Uh, we are using the value from the datasheet to calculate suitable resistance value for this circuit. As you can see, we also changed the resistor value that we got into ELE355 standard. Let's move to the result. So this is our simulation result. As you can see, the LED turn on when the switch is connected, and beside that, we can see that the current value that we estimated and from the result is not quite different. So we conclude that the simulation works and the resistor value is suitable for the real circuit. So that's all for the simulation result. Conclusion. From the simulation, the circuit is able to work as it should be. The result and the assumption shows only small difference in value. So we conclude that this project worked as it intended to, and we hope that this project will become a very helpful guide for those who try to build their own system. So this is one of the way you can design a water level control system using transistor BC547B. There's a lot more transistors that are available in the market, and we hope that this video will become a very helpful guide for those who want to try building their own system. So that's all from us. Thank you.